All right, so we're going to be doing lesson 32.1, which is the square root method. So we are going to be able to solve quadratic equations by the square root method. And then we're going to be able to provide some examples of quadratic equations having a given number of real solutions. So typically when we've been talking about quadratic equations, we've been talking about functions of the form y equals ax squared plus bx plus c. Now, when we're dealing with these types of quadratic equations, really we have been focusing on solving these by factoring because we have an x squared and an x, and we can't combine those two terms because they're not like. But as we have seen, there are some quadratics that don't actually have this bx term that we can solve with a little bit simpler of a method rather than factoring. So we may have quadratics of the form y equals ax squared plus c. And notice with this, the only variable we'll have is this x squared, so we'll be able to use our knowledge of solving equations to solve this just with the square root method. We may also have quadratics of the form x plus h, some number squared, which again, we are only dealing with this one variable, so we can use inverse variations or inverse operations to isolate it. Oops. So we're going to be using the square root method. So just going down, again, we're going to be skipping through these just to get to the main point. I don't want my lessons videos to be too long. But we're going to be solving these quadratics. So it says solve each equation, be prepared to discuss your solution methods with your classmates. So now normally when we're solving quadratics, we want them to be equal to 0. That way we are figuring out when y is 0, what is x. That's really what we're doing here, except our quadratic isn't x squared equals 49. Our quadratic that we're solving is x squared minus 49 is equal to 0. So that's actually the quadratic we're solving, except we start off with using inverse operations to get the x squared on its own. So just solving this for the value of x, well, in order to undo squaring something, what we can do is we can square root it. If I square root something on the left side, property of equality tells me I must square root it on the right side. Square rooting something undoes squaring it. So taking the square root of x squared just gives me x. And the square root of 49, well, we're looking for which two numbers multiply together to be 49. Many of us will say 7. However, it's actually the case that it's the positive version of 7 or the negative version of 7. So when we square root a number, we're going to have the positive or negative version of that number because a positive times a positive is a positive and a negative times a negative is a positive. So 7 times 7 is 49 and negative 7 times negative 7 is 49. So my solutions to the quadratic are 7 and negative 7. We can also do this on b, square root x squared. That would give me x. Property of equality tells me I must do it to the other side. So that means I'm dealing with the positive or negative version of the square root of 100, which is 10. Again, doing the same thing with c. I'm going to take the square root of x squared, which will give me x. That would require me to do the square root of 15. Now, 15 is not a perfect square, so we're just going to estimate it to the nearest tenth using a calculator. So the square root of 15 is 3.872. So we're going to round that to 3.9. So the positive or negative version of 3.9, or you could leave it as the square root of 15 if you want an exact answer. D gets a little bit more complicated because we have this value of x squared being multiplied with 2. So we still need to use our inverse operations to isolate x. Well, in order to isolate x, that means I need to isolate x squared. So we're still undoing in the order of SADMEP. So we need to undo our subtraction addition first, then our multiplication division, and then our exponents. So we actually need to get rid of this multiplication first. And in order to undo multiplying x squared with 2, I'm going to want to divide both sides by 2. So I get x squared is equal to 9. Now I can undo the exponent, so I would square root it. And x would equal then the positive or negative version of 3. Again, same thing with E, F, and G. I need to get the x squared on its own. So for E, I would need to add 4 to both sides. So I'd get x squared is equal to 4. Now I can undo that exponent, so I can square root it. So x would equal the positive or negative version of 2. I can do the same thing with F. Let's use yellow. I would subtract 2, subtract 2. So I would have x squared is equal to negative 2. Now, when we square root both sides to get x on its own, it's actually the case that I cannot square root a negative number. I get an imaginary number. So if I'm taking the square root of a negative number, I'm going to have no real solutions. And we'll get into what types of solutions that would, be. So then scrolling. Now that really messed up where my, can we, going to G, hopefully. Okay, so that fixed it enough to where I don't need to have something in my screen. So I would subtract 3 on both sides. So I get x squared is equal to 0. Square root. Well, the square root of 0 is 0. And this would be the one case where we don't have the positive or negative version of the number, as 0 is not a positive nor a negative. So it says refer to the equations in item 1 and their solutions. What do the equations have in common? Well, all of those equations had an x squared, so they're all quadratics. And B says, what type of numbers are represented by the solutions of these equations? Well, except for F, where we had no real solutions, I'm going to clear the screen. The types of numbers represented by the solutions were all real numbers. All real numbers. Except F. Except F, where we had no real solutions. How many solutions do the equations have? Well, most of them had 2 solutions. So how many solutions do all the equations have? 2 solutions, with the exception of F and G, which had no real solutions or 1. Then we're going to skip D because it has to do with the story that these problems were set up in. And we're actually going to go to example A, where it says solve this using the square roots. So this is, again, just like we were doing earlier, just solving for x. And so that required us to undo in the order of SADMEP. And that was actually on the Cami one. So in order to get x on its own, I need to get the x squared on its own. In order to get the x squared on its own, I needed to get the 3x squared on its own. So I add 6 to both sides. Then I need to get rid of the times 3. So I divide by 3. So I get x squared is equal to 2. And then we could, in order to get rid of the x squared, we would square root it. So we get the positive or negative version of 2. So the positive version of the square root of 2 or the negative version of the square root of 2, we can actually use a calculator and do the square root of 2. So we get positive 1.4 or negative 1.4. So we're going to do that with A, B, and C, solving for x squared. If you want to pause the video now and try these on your own, feel free. If not, then just stick along with us. So in order to get x squared on its own, I would need to add 10 to both sides. So I get x squared is equal to 11. Square root it. So x would equal the positive or negative version of the square root of 11, which is 3.16. So estimating to the nearest tenth, so 3 I'm sorry, 3.316, so 3.3. I can do the same thing with b, is I need to get the x squared on its own, so I need to get rid of this dividing by 4, so multiply by 4. So x squared is equal to 4. Square root both sides. So we can actually square root 4, which would get the positive or negative version of 2. And then we can solve for c. To get x squared on its own, I need to get the 4x squared on its own. So I need to get rid of this minus 6. So we would need to add 6 to both sides. So that would give me 4x squared is equal to 20. Then I would need to get rid of this times by 4 by dividing by 4. So we get x squared is equal to 5. Again, square rooting everything. We get x is equal to the positive negative version of the square root of 5, which rounding to the nearest tenth would be 2.2. So positive 2.2 or negative 2.2. So our quadratic equations either had 0 solutions, real solutions, so when we were taking the square root of a negative, 1 solution, or 2 real solutions. So it says fill in the table below. Fill in the table below with the equations from the first page that represent the possible number of solutions. So if we had 2 real solutions, that would mean we had x squared equals a positive number. Because then when we square root it, we'd get the positive or negative version of the square root of that number. So like x squared equals 49. We have x equaling positive 7 or x equaling negative 7. We could have had 1 real solution, which is when x squared equals 0. Because when we square root that, square root of 0 is 0. So x squared equaling 0. When we had no real solutions, that means we were taking the square root of a negative number, because we can't square root negative numbers, because we'd get which we'll get into, taking the square root of negative. But that would be like x squared equaling negative 4. We cannot do that and get a real solution. So we've been dealing with problems that had just an x squared, but we can also solve quadratics that are in the form, and I'm going to skip down to example B, of the form, if x plus 2, all of that being squared equals 66. Because in order to get the x plus 2 on its own, all we need to do is square root that. So looking at this example, I would need to square root the x plus 2 squared. That would give me just the x plus 2. Property of equality tells me I need to do that on both sides. So then I'd be dealing with the positive or negative version of the square root of 66. We'll still need to get x on its own. So I would need to get rid of the minus 2. I would need to get rid of the plus 2, so I would subtract 2 on both sides. So I would get negative 2 plus the square root of 66, or negative 2 minus the square root of 66, which then, using our calculator, we can estimate those values. Going to be try these. We can try these. So again, in order to get the x on its own, I need to undo the squaring and then the subtract 5. This is still following SADMAP, even though it seems like, I should undo my subtraction first. Well, I need to, what I really have going on in here is I have exponents in parentheses. And notice that my exponents I need to undo first before I can undo my parentheses. So that's actually the case that's happening here. So I need to undo those exponents. So to undo squaring something, I'll square root it. So I'm left with x minus 5, and the square root of 21 is actually the positive or negative version of 11. So then to get x on its own, I need to add 5. So x could equal positive 11 plus 5, or negative 11 plus 5, which would be 16, or negative 6. So those would be my two solutions for A. We can, again, do the same thing for B. Just for sake of time, I'm just going to jump to C. because this does require me to solve this by factoring, which it will actually end up with the same two binomials. So since I'm dealing with a equaling 1, that means my two binomials are x and x. So I need two numbers that multiply together to be 36 and add together to be negative 12. Well, both those numbers then would be negative 6 times negative 6. Hold on. Sorry, my dogs were being loud. So negative 6 times negative 6 is positive 36 and add together to be negative 12. So it's actually the case that the two binomials are the same, x minus 6 and x minus 6, which again we can rewrite as x minus 6 squared equaling 2. So then again, solving this, we would subtract, or we would square root both sides. So we get x minus 6 equals the positive negative version of the square root of 2, which then we'd add 6 to both sides. So x would equal positive square root of 2 plus 6, or negative square root of 2 plus 6. Square root of 2 then would be 1.4, so it would be 1.4 plus 6, or negative 1.4 plus 6. And we can go through and do that math as well. If you have any questions, please let me know. We'll continue to work on this in class.